Here in this situation, a sled with a rider starts from rest at the top of a 50-meter long hill with a slope of 10 degrees. The slope is frictionless. When the sled reaches the bottom, there is some friction causing the sled to slow at a rate of negative 0.4 meters per second squared. What is the total time from the start to the moment the sled stops in the level surface? So in terms of a drawing, we have the incline, and then it hits the horizontal surface and keeps on going. So in terms of givens, I'm going to have the initial conditions up here. We'll call those S, T, and V. 0, 0, 0, and we're starting from, this is 0 position. So 0 time is 0, and velocity starts from rest is 0. We get to the bottom, so it's going to be a new position, 1, T1, V1, and then eventually it's going to stop, S2, T2, V2. So we pick up speed, arrows get longer, velocity vectors get longer. Then it's more of a gradual because the acceleration is much smaller. These arrows get shorter, 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 and then eventually stop. Okay, the bottom of the hill. You have to figure out, it says 50-meter long hill, not high hill, long. So this is 50. Time is unknown, it's not given. Velocity is unknown. Final position is unknown. Final time is unknown, but final velocity is known. The slide's going to come to rest, or 0 meters per second. Acceleration is here, and that is at the negative 0.4 meters per second squared. The acceleration down the incline is g sine theta. We learned that a couple slides ago, or a couple pages ago. So in this case, it's 9.8 sine of 10 degrees. And I have a calculator here. Let's see what that is. Alright, so I get an acceleration of 1.7 meters per second squared. Alright, the goal here is to get the total time. So to get the total time, we have two different acceleration rates taking place. One down the incline, one as it slows on the level surface. So we'll solve for the time here, and then add to that time this time, and then the total time will be the final answer. So we'll just say that total time equals t1 minus t0, that time interval for the incline, plus t2 minus t1. Add those two together, that is the total time of the whole motion. Down the incline, we want to get the time. We do not know velocity, so we use the same formula we did in the previous problem. S final SI plus VI delta T plus 1/2 A delta T time interval squared. Starts from rest, that's 0. So you rearrange it like we did before. Delta T ends up to be the square root SF minus, SI 1/2 A So we have 50 meters is how far it goes. This isn't equals. It just keeps on wanting to disappear. 1/2 of 1.7. And I've done that already, and that works out to be 10.8 seconds. Pretty slow. Long time for that. I guess it's starting from rest. Gradual incline. So that would be equivalent to t1 minus t0. The other one, we need to figure out the time. A little trickier because we do not know how far it travels, and nor do we have this velocity. It's like an initial velocity. So let's see. What I did is I used this relationship, v1 equals VO plus A delta t. So for the velocity at the bottom, so that would be 0 plus 1.7 times, let's see, we just solved for that time, so that would be 10.8. So what I'm doing here is solving for the velocity right here. We're accelerating. We now know the time. We can solve for anything else. So it would be 1.7 times 10.8, and we get an answer of 18.4 meters per second. Okay, so that's what we end up right at this moment. Okay, I don't know if you're following that, but this is going to be 18.4 meters per second. We come to a stop, we know acceleration, so then we can use the same formula. So again, it's V, now this would be V2, that's the final. Initial would be V1 plus A delta t. This is between 1 and 2. And this is the time between 1 and 2. So I'll solve that for time. So it would be V2 minus V1 all over the acceleration rate, which we already know. And it gives us that time interval. Final velocity, it comes to a stop, so this is 0 minus 18.4 divided by the acceleration, which I think, let's go back up to it. Negative 0.4 right there, negative 0.4. Do the math, that comes to, let's just do it, 18.4 divided by 0.4. I got 46 seconds. So the total time, t total, is going to be the sum of those two. So we're talking 10.8 down the incline plus 46, which looks like 56.8. Whoops. 56.8. Okay. That's all.